All right. I haven't had much time to work on this, so I'm just letting it run until I do have time, but just to see what it does. I think it's slowing down now as far as the number of mutations. 10 hours ago, I was at uh, 356. The most changes any one machine uh, was 356 from the original copy. Now it's at 361, like 10 hours later. So it has changed. Before there were 4 lines, and they were multiple layers. And then what I was seeing was every so often, like a whole layer would come off, and it would all move toward one of these other lines. Um, and most of them would have 2 or 3 layers of these organisms. Now it's all these lines are generally pretty skinny, like one layer deep. And then what I'm seeing is it's like when when one of them die, it creates a hole in the chain here, and then when one uh, when one moves over to one of these lines of organisms, they just like move up the line, and it's like they looking for an open spot, and then they move into the open spot. I can see why it's doing this. When it I have it coded when it reproduces, it eats some food and reproduces, it'll spawn itself 20 copies of itself randomly all over the map. So um, by having these lines of organisms, like where they look pretty equal distant. So no matter where no matter where these organisms spawn, they probably have a really good uh, mortality rate. I mean, it's like I don't think it's anything like in the beginning where they'll die right away. Most of them will die right away just because they can't find food. No matter where they randomly appear on the map, they're gonna be moving like um, up and over, and then they're just gonna find the nearest chain here. And then also, uh, like when one of them dies, the one right next to it's gonna have a food source like right next to them. So they all have pretty easy access to food then. Um, yeah, it looks like a very stable and it's efficient. And, you're not going to see any death from a starvation when it is getting everyone fed as fast as possible. I mean, I'm uh, probably gonna let it run until I have time to work on it. What I could do is go grab the machine. Once I develop the interface better, I want it where you could easily transport one organism to another. So you can imagine like doing the same thing, maybe 10 other instances, and they all develop different ways, and then you take all 10 of those and then put them on the same world and then see what happens. And get uh, maybe um, force them to have to coexist, because in this example, I just started out with a single organism, and they just stayed harmonious because they're all almost the same code. But maybe if you started out with several different kinds, where they would either have to try to get the other one to go extinct, or um, if they couldn't do that, they had to either develop like a symbiotic relationship or competitive relationship. I think the competitive would be the most interesting. Um, Then you'd have like an arms race, where you have to. That's where I could see maybe intelligence spawning, or see vast improvements where one has to keep outdoing the other. I could show the code and show how I'm going to copy this, make a copy of this particular machine. This is after 12 million units of time had passed. So there's the data structure of the organism. There's the Turing machine, and it's got 63 states. Yeah, so he's got like each of the connections to the states. Most of them don't have connections themselves. It's kind of like in the other one. Um, they just serve as final output, the final Turing state. This one has 9 connections. So I'll call the encode Turing machine command to get the All right, so there's a lot more states compared to the second copy in the previous video. All right. So I'll save this off. So what I can do with this code here, there's a constructor for the life form, and all you gotta do is paste the string into that constructor, and it does the same thing as creating a copy of that life form in that world. Yeah, right here, just pasting that string into this constructor here. And where it started out was just this machine here that uh, it would look around and um, then move. Um, yeah, look around. It started out as just a simple organism that had a piece of food next to it, and it says, "Look around for food. If you don't see any, move left 1 square. If you do see some, then start moving toward it, and then once you get to it, eat it." Now, if I would have started out with look around, if you don't see any food, move left. Um, uh, and then you see food, then walk toward it and eat. Now, if I would have added to like one more state that just says, if you see another unit, walk toward the unit, and once you get to the unit, attack. Um, that would create a situation where you got two units that are going to both try to attack each other um, when they intersect, and then there's going to be a selective pressure to try to get a competitive edge. So maybe it'll develop a mutation to when you see another of its kind, you know that it's going to try to attack you, so try to back away or try to evade it. And then the other one will be like, the other one's going to have a pressure to try to get around those changes. And then it'll try to maybe anticipate its attempt to evade. And then the other one will try to anticipate the other one's attempt to anticipate to evade. See, that's where I think if by having more than just one kind of organism, there's already competition right away instead of this harmonious thing where they found a way to. Another thing is I did cap off the. I have a cap on the population limit. Uh, it's where they're eating. That's they eat, and then causes the food to lose its amount. And yeah, right here, like I have a population population control. I don't allow more than 1,000 um, organisms on the map. So it keeps count of how many there are. Well, I should say this isn't quite. It is able to go a little bit above it, but it's like when you get near, or when you're well below the max, and you reproduce, you create 20. And if it's within between 20 and the limit, it'll just when they eat, they just or if the number of life forms is greater than the limit, then when you eat, it just won't spawn anymore. And then otherwise, you'll just if you're within the 20 unit limit of the max, then you'll just spawn a single kid. So that's like a population control. So they're probably like behaving this way also because of the population cap. If I were to change that population cap, don't know, they would have to start adapting to that and be able to um, find a stable environment where they can stop rampant uh, population. I wanted some kind of limit so you wouldn't, so there wouldn't be so many that where it takes forever to evaluate a unit at a time. But it could have gone higher, and yeah, it might have been interesting to see what happens there. And then for the mutations, this is the copy constructor where it makes a copy of itself. And so this is where it makes a copy of itself, but then it decides whether to mutate or not as well. So it's like a 10% chance of mutation uh, for each one. I mean, it's a while loop, so it's potentially, if you 1 out of 100 times, you'll have two mutations in the same um, in one generation, or 1 out of 1,000 times you'll have 3 mutations. So if it ever hit like a local maximum where it was stuck, and let's say in order to get unstuck, you needed four specific mutations to get either move up a level or move down a level, so you can move up a level. It would be possible by chance to hit it over time because of the because I have it so I could any number of mutations is possible. And the way it mutates is got 9 different kinds of mutations. So at first it sees like how many different kinds of mutations are possible. And it, you know, gets a list of a count of how many of those are possible. Then it selects one of the possible mutations available, and then it performs that mutation. So they could either turn a regular state into a final state. It's like turning one of these circles into a double circle, where the program terminates and returns whatever output is on its tape, or unfinalize it, so remove the double circle, and I also have it create another connection so it just doesn't crash. Or remove a random state, so it removes one of those circles. That took a little bit of trickiness because of the I didn't want to actually that one yeah, I think the way I have that one, it's only removable if there's only one connection to it. I did that for like make it a little simpler. Adding a random state, you can only do that if there's an available connection. Like if all the connections from one state are being used, every single possible input is already pointing to some other state, and there's no room to add another state from that particular state. So, then there's like these couple of these three different mutations for randomly changing one of these 3 values here. Or removing a random. This is the one, remove random connection. It was kind of a pain. I needed to create another. I needed to create. Originally, I just had each state in the structure of it to say what state they're pointing to. But I also, for efficiency reasons, I also ended up having to store everything that's pointing to it, because when I put in the option to remove a connection, I didn't want to create dead code. Like if this connection were to be removed, there'd be no way for um, the initial state. There'd be no way to reach this code, and then anytime you have a mutation after that, it would be unchecked, and you just accumulate a lot of. Most of your mutations would accumulate in here, and it would be unlikely to actually affect the organism. And I wanted the changes to actually count, so I have it like check like before you remove a connection, is it going to create dead code? Like a spot in the code that it can't reach. So there has to be at least one connection besides it pointing to itself. It has to be at least one connection before you can remove. Yep. But I'll let it run. And it would be nice, like, to have it so it can save. I see some ways to do that where you can just save the whole data structure as like an XML and load it, and hopefully it's pretty easy. I don't need to go into developing my own saving and loading. I want to be able to save and load, and that way I can stop this and I can resume it later and take all the time I want to run as many as many times as I want.